right, Secondary Math 1 class. We are going to spend today practicing simplifying radicals a little more. Okay, we learned about this last time in class, and honestly, this is a hard concept, you guys. If you didn't feel too confident after the last lesson, that's okay. We're not going to get it perfect the first try, right? So let's go ahead and get right into our notes. If you do not have a printer at home, I highly recommend that you just get a blank piece of paper and you write down the notes anyway, okay? Math is super easy to just copy down, okay? So you don't have to turn in those notes, but it's a recommendation, okay? So for number 1, we're gonna do the same thing we did last time. It says to list the first 11 perfect squares. Okay, so let's make a list from 1 to 10. 4, 5, 6, 7, 8, 9, and 10. Okay, well now that we have our list from 1 to 10, we are going to actually figure out what they are when we square them, right? Okay, so what is 1 times 1? Okay, so right now on your list, multiply each of these numbers by themselves. Okay, so 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. Okay, well now another way to rewrite all of these guys is 1 times 1 is 1 squared. 2 times 2 is 2 squared, or 2 to the second power, right? 3 times 3, 3 squared, 4 times 4, okay, and so on. Let's finish our list. Okay, 9 squared and 10 squared. Okay, so this is all just a way of rewriting what it means when we multiply it by itself, right? 1 times 1 is 1 squared. 5 times 5 is 5 squared. 9 times 9 is 9 squared. Okay, well now let's figure out what are these actual numbers. Okay, what is 1 times 1 or 1 squared? That's just going to give me 1. Okay, 2 times 2 or 2 squared is 4. 3 times 3 or 3 squared, remember we're multiplying here, it's going to give me 9. 4 times 4 or 4 squared, 16. 5 times 5 or 5 squared, 25. 6 times 6 or 6 squared, 36. 7 times 7 or 7 squared, 49. 8 times 8 or 8 squared, 64. 9 times 9 or 9 squared, 81. And last, 10 times 10 or 10 squared, 100. Okay, this list is really going to help us. These numbers in blue are called perfect squares. Whoops, might want to spell perfect correctly. Perfect squares. Okay, and last time, if you remember, they're called perfect squares because when we draw them in an array, they actually do make a perfect square. Okay? So, now what I want you guys to do, just like last time, is I want you to look at these blue numbers, and I want you to look at 2 through 9 on your paper. Okay? 2 through 9 on your paper. And I want you to see if there are any perfect squares just inside the radical, okay, just under the ramp. Okay, notice on 6 through 9, just look at the numbers underneath the radicals. Do not pay attention to the number in front, just underneath the radicals. Okay, so if I'm looking at these, I know that 125 is not on my list. 16, ooh, let's put a star by these guys, the ones that are on my list. 16 is on my list. 64 is on my list. 18 is not on my list. Ooh, 81 is on my list. Okay, remember we're just looking at the number inside the radical, so 81. 81 is on my list. 50 is not on my list. 27 is not on my list. And 324 is not on my list. Okay, so now that we've put a star, so I have stars by 3, 4, and 6, okay, because the numbers underneath the radicals were all on my list up here in blue. Okay? So now that we have identified numbers that are perfect squares, let's go ahead and practice simplifying the radical. Okay, so when we're simplifying the radical, remember, we're always thinking divide. Okay, we're using division and multiplication here. So when we're simplifying the radical, we're thinking divide. Okay, so let me zoom out just a little bit. Okay, there we go. Okay, so we're thinking divide. So on number 2, we didn't put a star by number 2 because 125 is not a perfect square. There's no number that multiplies by itself to give us 125. So what we need to do is divide it. Okay, I see that 125 is not an even number, but I see that it ends with a 5. Okay, that means we can divide it by 5. Okay, well, when we divide 125 by 5, and I'm using a calculator right now, you're more than welcome to do that as well, we get 25. Or in other words, 5 times 25 will give me 125. Okay, now, how many groups of numbers are we looking for in order to leave the radical? Okay, think last time. Okay, we're thinking of we need a pair. So we need 2 numbers of the same numbers in order to go on a date and leave the radical, right? Stupid analogy, but you guys remember it. Okay, so we can't break 5 down anymore. 5 is a prime number. Breaking 5 down wouldn't help us. It's just 5 and 1. So we're going to keep that as 5. But let's break 25 down. Again, it ends with a 5. So let's divide it again by 5. Okay, when I divide 25 by 5, I'm also going to get 5. Okay, we've broken it down to where we cannot break it down anymore. So now the question is, where is a pair of the same numbers that can group up, can create a couple, and go on a date? Okay, well, I see 2 5s right here, and I also see 2 5s right there. Hint, it does not matter which 2 5s you take. I'm going to take these 2. Okay, these 2 5s become one couple. Think 2 people become one couple. So one couple got to leave the radical. Okay, well, how many people or what number has to stay inside my radical? They couldn't pair up and go on the date. Okay, remember, we broke down 125 and 25. So all that's left are those 3 5s. 2 of them paired up to create the one couple, but one of them has to stay inside. Okay, so our final answer is 5 root 5. Okay, it's not a nice and pretty whole number because 125 is not a perfect square. Okay, let's look at number 3. Ooh, we put a star by number 3. We put a star by number 3 because 16 is on my list. Okay, that means I already have a pair of numbers. Okay, or in other words, the square root of 16 is 4. Okay, well, why is it 4? That's because if we wanted to divide 16 by 4 and 4, look at that. We already have a pair of numbers that can couple up and leave, okay? No one had to stay inside the radical, okay? So it's a nice whole number. The square root of 16 equals 4. Okay, what about number 4? We also put a star by number 4. Okay, where is, or what is the square root of 64? What number multiplies by itself to give me 64? Okay, we know that the square root of 64 is 8, because if we wanted to break this down, 8 and 8, there we go. There's automatically our pair of numbers that can leave, and no one has to stay inside. So the square root of 64 is 8. Okay, let's look at number 5. 18 is not a perfect square, meaning 18 is nowhere on our list up here. Okay, so we need to break it down or divide it. Okay, how do we want to divide 18? Okay, well, hint, it doesn't really matter how you divide it. You'll get the same answer as long as you're dividing it by numbers that actually can go into it. Okay, so 5, for example, doesn't go into 18, so we can't divide it by 5. But it is an even number, so we can divide it by 2. Okay, so now that I've divided 18 by 2, I'm going to get 9 on that side. Okay, I don't have a pair of numbers yet that can couple up and leave my radical. 2, we can't break down anymore because it's only factors, or 2 and 1. Okay, so that is as broken down as it can be. But 9 we can break down or divide. Okay, we can divide 9 by 3. Okay, and 9 divided by 3 is going to give me 3. Okay, so we've broken down these numbers as far as they'll go. So don't look at 18 or 9. We only have 2, 3, and 3. So what is my number that can couple up and leave the radical? Couple up and go on a date. It's going to be that 3. Okay, so 3 created one couple. Remember, they create one couple that gets to leave my radical. Okay, what number then has to stay inside my radical? It could not couple up. It's going to be that 2. Okay, remember we already broke down 18 and 9. They're not there anymore. So we just had the 3 that coupled up and created one couple, and then 2 that had to stay inside. Okay, let's look at number 6. Okay, do you guys notice the difference between 2 through 5 and 6 through 9? Okay, well 2 through 5, we didn't have any numbers out in front of our radical. Look at 6 through 9. We do. We have numbers out in front. Okay, we're going to ignore those for just a second. Okay, let's just pretend like we have a radical of 81, square root of 81. Okay, well what's so special about 81? We put a star by it. It's on our list. Okay, so what is the number that multiplies by itself to give me 81? That's 9. Okay, so what this actually turns into is 9. Okay, so we almost get rid of the square root of 81. That turned into a 9. So we're going to rewrite this as 9 underneath. But now we have to bring down our -5. Okay, what's actually happening here now is we are multiplying these two. Okay, so what is 5, or -5, excuse me, times 9? You can use a calculator. -5 times 9 is going to give me -45. Okay, that one looks nice and pretty with no radicals left over because the square root of 81 is a whole number. Okay, it's 9. It doesn't look ugly like the square root of 125, right? Okay, so we simplified the radical, which came out nice and pretty at 9, and then all we had to do was multiply it by what was out in front. Okay, so we'll make that note on our paper. Okay, so we had to multiply by the number in front. Okay, so we're going to simplify our radical, which we did, and then multiply it by the number in front. Okay, so let's do that on number 7, because 7 we couldn't put a star by. Okay, so let's just look at the square root of 50. We're going to ignore this 6 for a second. Okay, well, how do you guys want to divide 50? Okay, so I see that it's an even number. It also ends with a 0. We can divide it a few ways here. Okay, if you just said, hey, it's an even number, we can always just divide it by 2. Okay, when I divide 50 by 2, I'm going to get 25. Okay, I don't see a pair of numbers yet that can leave, but I do see 25, and 25 helps me because it's a perfect square number, meaning when I divide it by 5, I get 5. Okay, so we're going to treat this exactly the same way as if we're just ignoring this 6. So what number gets to couple up and leave my radical? The 5. Okay, so the 5 gets to leave my radical. What number has to stay in? The 2. Okay, well, here's where we would have been done on these guys. But now our second step is to multiply. Now we bring in the 6 that was in front, And since it was already in front, we have to multiply it by what we took out of the radical. Okay, so this 6 is now multiplying to the 5, and that's our last step. Okay, the square root of 2 stays the square root of 2. He couldn't come out on the date. He doesn't get to multiply. Okay, well, what is 6 times 5? What is that going to simplify to? 6 times 5 gives me 30. Root 2 stays the same. So our final answer is 30 root 2. Okay, let's do the same thing. 8 and 9 are exactly the same steps. Okay, so we're going to ignore the -7 for now. We're just going to pretend like this is a root 27. Okay, well, it's not a perfect square. Okay, it wasn't on our list, so we need to divide it up. Okay, well, 27 is not an even number, right? So we can't divide it by 2. But I know we can divide it by 3. Okay, what is 27 divided by 3? It's going to give me 9. Okay, I don't see a pair of numbers that can leave my radical yet, but I know I can divide 9 to 3 and 3. Okay, well, now looking at my 3 3's, what is my number that can pair up and leave the radical? Okay, doesn't matter which 2 3's you grab. I'm going to grab these guys, but they create one couple. So one couple of 3 got to leave my radical. 1 3 had to stay inside. Okay, we're not done yet because now we have to bring in the -7 that was already out front. Okay, so this guy comes out here. -7 is now multiplying to the 3 that came out. Okay, so our very last step, what is -7 times 3? -7 times 3 is going to give me -21. Bring down your root 3. It doesn't change. And there is our final answer. Okay, let's do one more. Holy smokes, look at 324. That is a huge number, but don't worry. Okay, we're going to break it down the exact same way. Okay, so let's ignore the 9 for now, and we're just going to keep dividing 324. Okay, so I can say 324 is an even number, ends with a 0, 2, 4, 6, 8. Okay, so we can divide it by 2. 324 divided by 2. Whoops, I typed it in wrong. 324 divided by 2. That will give me 162. Okay, still a big number. That's okay. Let's do the same thing. It's still even. We can break it up by 2's again. Okay, what is 162 divided by 2? 81. Okay, ooh, I see a pair of numbers. Okay, so let's just circle these guys and make a note that they are going to create a couple. But we can continue to break down 81. Okay, so let's divide it. Okay, so how can we divide 81? Hint, let's look up here on our list. We can divide 9 and 9. Okay, so 81 turns into a 9 and a 9. Oh my gosh, there's another pair that can leave. So what pairs of numbers got to leave my radical? We actually had a 2 that could leave, but then we also had a 9 that could leave. Okay, hint, we're always multiplying these. Okay, let's make that note on our paper. When they get to leave, they multiply. Multiply. Okay. Were there any numbers that had to stay in? Hint, we broke these down, so don't look at them. No numbers had to stay in. So our very last step is just to multiply the number that was already out front. So now we have another 9 being multiplied. Okay, so all we got to do to get our answer is multiply 9 times 2 times 9. So you can do that in a calculator, or you can do it in your head. Okay, I would probably do 9 times 9 would give me, Yep, 81. And then 81 times 2 is going to give me 162. Okay, that one was probably the hardest example on our notes today. Okay, so rewind it, have me look over it again, rewrite it again if you have to. But those are your notes today, you guys. You have an assignment that goes with it. Both the blank copy and the filled out copy of the notes will be on Canvas. Okay.